We, the Tower School 8th grade, built Rube Goldberg machines in groups. Rube Goldberg is an American cartoonist who drew very complex machines that performed simple tasks. His most famous work is the self-operating napkin. Although Rube Goldberg's cartoons were meant to be humorous, the actual machines are often based in science. Most commonly, the Rube Goldberg machine is used in simple physics classes. Motion, acceleration, force, and Newton's laws are all easily portrayed through Rube Goldberg machines, all of which are present in our machine in one way or another. Most prominently, motion, because our entire project would not work if it didn't move. Newton's first law states that an object at rest stays at rest unless acted upon by a non-zero net force. Inversely, an object in motion stays in motion unless acted upon by a non-zero net force. Newton's second law states that acceleration depends on mass and net force. Newton's third law states that if an object exerts a force on another object, the other object exerts a force of an equal strength in the opposite direction. This short clip exemplifies all three laws. The white marble stays at rest until a non-zero net force acts upon it. When the metal marble hits the white marble exerts the same force back, but the metal marble causes the white marble to accelerate. The first step was planning and brainstorming. All of the members of our group drew plans of what we wanted our machine to look like. We later realized that most of our plans were not applicable. Finally, we came up with a simple design that was physically just laid out, and we began preliminary construction. The beginning of the construction was the most difficult because we had to figure out how we want to build our entire project. After we had already finished the first part of our project, building became easier because we knew how to put things together and already had some practice. We continued to build more and more, always adding on to what we had built before. Over the course of 2.5 weeks, we designed and built our entire project. Throughout the entire process, we tested often. We built one new contraption, tested it, and moved on to the next new contraption until we had included all of the factors that we wanted to include. After testing, we always had to revise our ideas. Most of the tests did not go as planned, but that was what we were aiming for. Whenever we tested, and one aspect of our project didn't work, we fixed it, tested again and again and again until it did work. Half of the tests were spread out evenly throughout the building, but the other half of them happened when we had finished building everything, because we had to make everything completely reliable. The machine starts with the pull of a string which lifts a pipe up that contains a marble. The marble rolls through a system of inclined planes until it finally lands in a cup. When the cup falls, a piece of wood is lifted up, which releases 2 other marbles that then go into a funnel. They circle around in the funnel and go onto a curved track until they land on a straight track. They then hit a larger marble, which hits a lever, which causes a marble to get released on the top track. That marble hits 2 other marbles until the last marble, which is heavy, falls into a cup, which lifts a balloon up that contains baking soda. The baking soda falls into the vinegar, which is in the Erlenmeyer flask. The weight of the cup also causes another marble to be released because it's held back by a gate. The newly released marble hits another marble, which runs down a track and falls into a system of curves. The new marble falls into a small cup, which is attached to a pulley, and when the weight falls into the small cup, the other end of this pulley is lifted.
Sleigh bells ring, are you listening? In the lane, snow is glistening. A beautiful sight, we're happy tonight, walking in a winter wonderland. Gone away is the bluebird, here to stay is a new bird. Sing a love song while we stroll along, walking in a winter wonderland.